Hello. Thank you, everyone, for coming. Today, we're going to talk about observability in the context of GCP Cloud, Anthos, and we're going to do a deep dive on GKE for hybrid environments. I want to introduce here on stage with me, we're going to have Elizabeth. She's the technical lead for service monitoring and SLO monitoring. And Shoucong is the technical lead for GKE monitoring. They're going to help me with the demos. My name is Ruxanda. I'm a product manager working on service monitoring, SLO monitoring, and GKE monitoring at Google. So what we're going to be focusing on is observability principles. I'll try to talk to you a little bit about Anthos and GKE and the principles behind that and what we are trying to achieve by providing a single pane of glass. We're going to do 3 demos today based on customer user journeys. The first one is going to focus during the process of migration from on-prem to GCP. How do we maintain consistent observability across the 2 environments? Then I'm going to come on stage and we're going to talk a little bit around SRE best practices. And I want us to focus on the microservice model and how do we instrument and understand health of microservices at scale. And we're going to do a deep dive on SLOs, how to set up SLOs and how to think about SLOs. Then Elizabeth is going to come and help me to actually talk about how do we instrument these SLOs. So today, we are announcing the launch of the SLO API in beta that will allow you to set up SLOs on all of your environments. So she's going to show us how to do that for services that we understand and are created out of the box for us, and then for custom services, anything that you have deployed. In addition to that, we're going to talk about scale. When a microservice architecture is very small and you have 30 to 40 microservices, everything is easy. But when you have hundreds of them, we need to think about how to instrument from the first SLO to the 500th one with scale in mind. So we're going to talk about that process. So let's start with observability principles for Anthos and GKE. We fully understand that all of you have a very complex way when you think about your path to cloud or your path to modernization. And we understand there are many challenges there. A lot of our customers end up doing lift and shift, lift and optimize. There is an entire process for rebuild or improve and move. In all of these scenarios, the biggest problem that we have is that you can't have a single solution for every enterprise company. So what we need to do is to think about a modular way to empower you to have visibility on all of these scenarios. So this is what we try to do. There are 2 fundamental things that we care about: uniform visibility and maintaining context. So we're going to talk about how to do this. Anthos is a very good example in terms of how we are planning in terms of orchestration. So we are empowering customers to ensure that they can modernize on-prem if that is what makes sense for the value and the particular point in time of their application. We want to ensure that you can deploy and automate at scale, and you can easily manage and secure your application as well. The way we do this from an observability perspective, we allow customers to pick their observability solution of choice. The moment you deploy, for example, a GKE on-premises cluster as part of Anthos, the Stackdriver monitoring and logging agents are installed by default. And we extract system-level telemetry, which is made available to you out of the box, and it's part of your Anthos price. You don't have to pay extra for it. And there are 2 use cases for this. The first one, we make your system-level telemetry available to GCP support, which is fundamentally important for GCP to be able to understand and help you troubleshoot your on-prem environment. But we also make it available in the Cloud Platform console to allow you to actually get access to this data, understand it, alert on it, and be able to actually have a uniform observability there. If you want to keep all of your observability data on-prem, we have integrations with all of the large monitoring providers and be able to still have an observability solution for Anthos, even if you decide not to get your observability data to the cloud. More than that, what we are able to do is bring a single observability experience. If you have a GCP cluster on GKE as part of Anthos, and if you have a GKE on-prem cluster as well as part of Anthos, you can see them side by side in the same experience. Furthermore, if you, in addition to your on-prem and GKE clusters that you have as part of Anthos, you have another cluster that's part of Kubernetes engine, you can see that in the same UI. So what we are trying to build here is one single experience that allows you to see every single GKE environment that you have in one view and be able to compare and understand your metrics, your logs, your alerts, your traces. So next, we're going to focus on a particular user journey during migration. I'm going to invite Shoucong to come on stage and start setting up for the demo. But as we're going through this while he gets set up, I want us to think about this is a very typical critical user journey. As a developer, you want to be able to monitor your application during the migration process from on-prem to GCP. You want to have visibility as the traffic is moving from one to another. And while we do this, we are using a Hipster Shop app. This is a web application similar to a retail website where you can purchase several things. This is the architecture behind it. You have a cart service. There's a front end, a product catalog service. There are multiple languages. We have deployed this application both on the cloud and on-prem. It's running in parallel right now. And Shoucong is going to try to transfer traffic from on-prem to GCP, and we're going to see how do we monitor this transition. So Shoucong, please.
All right, thanks, Ruxanda. So this is Shoucong. I'm the technical lead working on GKE monitoring. So now I'm going to give you a short demo about how Stackdriver can help you get the basic observability during your cloud migration. So as we all know, as Ruxanda has mentioned, there are several paths that we can migrate from your on-prem environments into a cloud platform. So one of the paths is lift and shift. That basically means you replicate all your on-prem cluster stuff into a Google Cloud cluster, which is GKE, and then move the traffic over. So usually in like the regular enterprise, this process will take months or years. And then we need some observability to help us make sure our services are healthy. But in this demo, I will make it very quick in just 2 commands. This is the SSH terminal into my on-prem cluster. So to simulate the experience, I basically just use a load balancer. So I just scale down the traffic as I run like about 20 minutes ago. So I just scale down the traffic of my on-prem cluster. And then this is the cloud terminal, which is connecting to my GKE cluster. And I just spin up the traffic here. So then I'm going to show you how to use Stackdriver to see this basic functionality, observability. So in Google Cloud Console, now you can use Stackdriver monitoring in the context of a Google Cloud product. So I go directly in the console into the custom dashboard view. So I have created a custom dashboard called hybrid hipster shop. So this is the custom dashboard I created to reflect my hybrid environment. There are 4 charts in this custom dashboard. As you can see here, so the most interesting thing at this moment is like on the top right chart, there's aggregated HTTP request rate breakdown by the cluster. So as you can see, like I run the command like about 20 minutes ago, so my hipster on-prem cluster traffic has gone from 100 requests per second to nearly 0. And then my GKE on-prem cluster has spin up from like 20 to 100 each. And this looks reasonable to me. And then also on the top left chart, I have the HTTP request rate breaking down by service. but aggregated across the cluster. That means that each cluster in this hybrid environment, what's the current overall situation. And it seems like during the migration process, there's only a small fraction of moment that the traffic has spiked a little bit. But in general, like all the traffic seems to be within the same range. That means my migration process is moving healthily. I can also add more charts here, like if I want to see more things that I care about. For example, I can click on the Add Chart button, and then on the metric explorer, it pops up. I can type in the metrics I care. And in this case, I want to see like the top 3 CPU usage of my Kubernetes container within these hybrid environments. So the thing I will do here, so we'll just go the core CPU usage. And then group it by the service name, which is like here. And I turn on the outlier mode, which only show the top 3 one. I can click Save, and then you will just add it to the custom dashboard. OK, so now this is for the general like operational team. As a specific application people, I'm developing my services for the currency services, which I put a chart on the bottom right corner. As you can see, when I switch the traffic, it has started showing up in the hybrid and on the GKE environment, and then disappear on the hybrid one. But one thing I mentioned here, I observe is misbehaving, which is the error rate. When I do the cloud migration, I see the suspicious 500 rate showing up on my GKE cluster. This is the thing that I want to take a deeper look and debug, and I will leave it for the next demo when Elizabeth is on this stage. At this moment, I will hand the mic back to Ruxanda and welcome her back to on the stage. Thank you.
Thank you so much, Shoucong. So what we were able to see is that during the migration process, we can have visibility of clusters that are residing in very different places. But what we looked around was HTTP request, we looked at CPU, we had mostly a focused view of how your infrastructure is moving. But what is really important for us to do next is to think about how do we actually understand the service health. So we're going to talk a little bit about SRE best practices and SLOs next. One of the fundamental issues that we have within the large majority enterprise organizations is that we have very different, between developers and operators, very different goals. Developers focus on agility, ensuring that we can ship as much code and give us customers as many features as possible as soon as possible. Operators focus on stability. And this push and back between the two teams, while in some cases it is healthy, unfortunately, for the majority of cases, it tends to be not productive and it doesn't scale. And there is a lot of kind of personal animosity between two groups that should be collaborating and having a common goal. So what we have done throughout this has been a problem that people have identified and tried actively to solve. Agile solves for a great alignment between business and development. The DevOps form of working between operators and developers brings together development and operations. SRE is trying to take this model even further. The goal for SRE is to bring alignment of the entire organization, not just these two silos. So what SRE is trying to put forth is a culture and a practice aimed of breaking down the silos and barriers from the entire organization. So what we're trying to do here is to think how to actually break things down, implement gradual changes. It's not an all or nothing. We don't have to work on something and ship everything at once. Shipping gradual changes is in the best interest of our end customers. Measuring things, everything. It's really important for us to understand, are we building what our customers need? Are we building what we want to build? Leveraging tooling and automation. And we're going to talk about how to figure out the right way to balance individual and personal input into the experience with automating things that are prone to human error. Reducing organizational silos and getting, as I've said, the entire organization to work as a whole, and accepting failure as normal. This is the fundamental piece, and we're going to talk about understanding that most of the time you talk to somebody like in your company and they ask you, how much do we need to be up? And what they say is 100%. What the SRE team is trying to do is very simple. This is just a group of people that share a simple philosophy about how they should work and operate together. And they are doing this by a set of engineering tools and practices. I know it tends to be very overwhelming when we talk about SREs. I've had customers that said, I can't adopt this. I don't know how to hire these people. What we're going to try to talk to you about today is with your current setup, without changing anything in your application architecture, without hiring anyone, how can you implement this model in a way that is not disruptive? So this is what we need to talk about: reliability. And when we talk about reliability, let's think about this at a very simple way. The first fundamental, naive question you all need to ask is my service running or not? Is it up and down? And this is a simple question that everyone in this room should have an answer to. We need to instrument for that. And if your metrics are continuous and binary, and if something is up or down, this works well. However, a lot of you have distributed and complex systems that you work with. So in that scenario, we need to have a more nuanced definition of what service health means. We need to think about things like, is my service partially up? What is the quality of my service? How do my customers feel about it? And then we talk about kind of customer happiness as a way to trigger this. But taking it from the most simple and naive SLO definition to the most complex one, we actually have the exact same definition at the core of it. We have a definition of reliability, and then we have a way to measure it. It doesn't matter how complex an SLO is or how simple it is. It is an indicator, a measurement with a goal attached to it. The fundamental key, if we all leave today with one thought, is that no company should try to be 100% reliable. That is not a goal that anyone should strive for. It's actually not in the best interest of your customers to be 100% reliable. It means that you will never ship anything. You're going to completely stagnate. So then what is the goal here is for us to think about error budgets. And this is where we need to think about, as an organization, pick the things that you need in order to meet your end user needs. This is the fundamental question that you need to ask, is what is the amount of unavailability that your end user is willing to tolerate, and that is your error budget. And once you come up with that definition, that is very liberating, because when you get at the end of the month or at the end of the quarter and you didn't burn through your error budget, you can go have fun. You can go and start shipping things, doing experiments, having fun, and you know you're going to still have your end customer happy. So this is what you need to do, is to understand, okay, how much can I play with and not piss off anyone? And that's like a really fundamental and hard question to ask. SLOs gives you a very good measurement where you can ship fast, be agile, and still keep your end customer happy. And also keep your CTOs happy and CEOs happy, because you're meeting your SLOs. So what are some of the benefits of thinking through this error budget model? This is kind of shifting the way you're thinking about the world fundamentally. You need to have a meeting with everyone within your company. And I mean include UX design, UX research, business, finance, marketing, sales, engineering, operations, SRE, everyone that has an understanding of the end user experience, and agree upon a set of business goals that you all can share. That is actually the hardest part. Implementing SLOs is easy. But figuring out what the business cares and implementing SLOs on things that are meaningful to the end customer is fundamentally important. And once you do that, every person within your company shares the same goal. We are all working on the exact same set of values. And think about these when we talk about SLOs at this point and error budgets, every single service is important. Every single service that you care about should be measured. But not all services are customer-facing. Not all services you should be woken up in the middle of the night for. If you have a database that goes into your front end, you don't need to wake up at 3 o'clock in the morning when your database is down because it's not impacting your end customer. But your front end is critical. And understanding that and agreeing on that is fundamentally important. So let's talk about terms. I've used all of these acronyms of SLIs, SLOs, SLAs. Let's kind of set up the stage of what each and every one means. Fundamentally, an SLI is a measurement. It is a metric compared against a threshold. So whenever your service agreement is what your service level is acceptable or not. That's what you measure with an SLI. An SLO is the goal aggregated over the SLI over a window of period of time. So now you're actually thinking this is a mathematical bound error budget. So now you're thinking about your service in the terms of over this window period of time that you've set up. It could be 1 day, 3 days. It could be a rolling calendar period. It could be a particular like Monday to Sunday period. To what extent I'm exceeding the target error budget, the remaining error budget. And an SLA, this is the fundamental kind of conundrum here. This is the contract that you're going to make with your end customer. You make an agreement, and there are consequences. So at this point, the fundamental difference is that you're actually accountable. If your service is not down, you might need to refund money. Your support is going to file tickets. You make a commitment that within this amount of hours, we need to close a ticket. Within this amount of hours, we need to be available. Or for this amount of minutes a quarter, our website needs to be up. These are agreements and promises you make to your end customers. You need to know, am I keeping those promises? And this is what SLOs help you to do. You instrument your promises. I had a fascinating conversation today around kind of what are the first steps of thinking about which are the promises you're making to our customers. The promises we're making in our customers are in the documentation. You look at the documentation and you say, my product should do X. Are we measuring if the product actually does that? Is there a way for us to know if we are keeping the promises we're making it to our customers? So what SLO does, it gives you a single framework to think from business, development, and operations, and have one key measurement to track and bridge all of these domains. So remember when we talk about SRE best practices? These are the ways we can actually put them into practice. So shared ownership between devs and ops is key to reduce organizational silos. Having that shared mindset and mind frame to approach this is fundamentally important. Error budgets is the way we need to start thinking about accepting failure. You're never going to be 100% up. And the sooner you accept that, the easier it's going to be within your company to accept when you have an OMG, when things fail, and know how to mitigate for that. Smaller and gradual changes. This is really important to reduce cost of failure. You need to figure out ways where you can ship smaller pieces of code, have a clear playbook for doing rollbacks, understanding how to optimize and scale in a way that is safe for your company. We need to understand how to automate common use cases. Every single time somebody needs to go in and do something manually, Imagine two people that are actually following the exact same instrumentation document or playbook. They might make errors throughout the process. So automating this is really important. We're going to talk about automation and APIs as a key to set great records and documentation of the SLOs you're creating, but also make this reproducible for other people in your organization to use the same template. And finally, while it's fundamentally important to measure everything, measuring with reliability and toil in mind is the key here. While you can measure every single CPU on every VM or container that you have, and that would be meaningful in itself, having key SLOs set up and understanding the reliability of your system is the fundamental key to have one measurement that makes sense for every single microservice. What you want to achieve here is the ability for a CTO, a marketing person, a product person, every single developer in the company to be able to look at one microservice and understand how it's doing without knowing nothing about the code underneath it, but just understanding its SLOs and its targets and the criticality to the system. So I know all of you are really excited right now and want to go home and create your first SLO. I know that. But I also fully understand that that is overwhelming because you might have hundreds of microservices. You might have a lot of teammates that are not at this awesome talk, and they didn't hear how amazing SLOs are, and you have to go and convince them, and that is hard. The advice that I can give you that I've seen that works with very large enterprise customers that I worked with is start small. Pick one service, pick one developer team that is interested in this collaboration. Work with them, organize that meeting with the stakeholders, set up the goals for that one service. What you need to do is to have kind of that special unicorn that is able to champion this within the company. Culture is key. Doing this both top-down and bottom-up is the right approach. You need to advocate within your company about the benefits of SLOs and make sure that everyone feels psychologically safe to adopt this. This is not a metric of developers or operators. This is a shared metric of the organization, and it needs to be presented in that context. And then go and instrument your first SLO. It's as simple as that. Start with one SLO, show value for that, and later on, in order to scale this, try to get adoption. I've worked with large enterprise companies. When we demoed the product in EAP, they looked at it, they created it within the first 2 to 3 weeks, 3 to 5 SLOs, and it probably took us 6 months to actually instrument every single microservice in the company. And that is a very reasonable timeline. Do not expect changes overnight. Have patience with the people around you. Encourage them that this is the right path to go, but understand that it's a cultural shift. More than anything, it's a cultural shift. You don't need new people. You don't need to change your architecture, but you need to have the people in their company bought into this shared story. So next, we're actually going to do step 3 of that journey. We're going to try to instrument a few SLOs. I'm going to welcome Elizabeth to join me on stage, and while she sets up, we're going to talk about what she's going to demo. So as a developer, you want to instrument health measurement across an entire fleet of microservices. So the goal here is we want to focus our operators team on a small set of signals that affect the end user experience. So she already met with our product teams. She already met with our marketing. She came with an idea of, these are the SLOs I want to create. We have very clear objectives that were already defined, and now we want to get to the process of creating them. What we are trying to do, and what we're going to demo later on as well, is bring meaningful insights. SLOs alone do not solve the problem. Seeing SLOs in the context of metrics, logs, and alerts are going to give you a single context in a single tool of all of your telemetry in one place. There is no AI, there's not fancy machine learning. It's simple correlation of here are my metrics, here are my logs, my error budget is not looking good right now, and these are the alerts that are firing. That in itself can give you enough insights to understand what the root cause is, and do that at a glance. The second thing we want to improve with this experience is speed. This is the fundamental thing that we care about. We want to take every single low-level signal and abstract it into a high-level SLO evaluation of your performance. So traditionally, what would you do if an alert would fire? You're going to go into logs. You're going to filter those logs and go in left and right and try to figure out which is the right log that can give you an indication. Imagine that you're only looking at the logs that you care about for the particular time frame when the incident occurred for around this particular service with the underlying, let's say, containers underneath it with the metrics attached to it. That in itself, it's what, 5-10 minutes saved of you having to do filtering and preparing to the key things you care about. So, Elizabeth, show us how it's done.
Great. Thank you, Ruxanda. So, hello, my name is Elizabeth. Ruxanda has spent time describing the whys of SLOs. My job is to describe the how. We're going to start with a GCP project, Observability New, which has 2 applications running. One is Hipster Shop, which Shoucong showed us earlier. Another is Pet Shop, which is a similarly simple web application running a few microservices. We're going to set SLOs against those microservices. We're going to create alerts, and then we're going to show you the dashboard you can view to see all of your services' performances in one place. So to start, here is our view of service monitoring. Out of the box, service monitoring understands some application types, like Istio, like Google App Engine. We're able to automatically ingest those services. So we can already see here, the Hipster Shop microservices have been ingested. We could start setting an SLO against ad service right now. We're going to do that using the Google Cloud Monitoring API client. We're using Python. It's published in a few other languages, and of course you can do this all through curl commands, but we're going to work with Python. We import the library. We create a reference to the API itself, and we're going to store a reference to the project that we're observing, in this case, Observability New. Just to show you that this works and shows the same view as you currently have in the UI, we're going to pull up the current list of services in the project. Great, same view. So, Shoucong showed us earlier that he's responsible for the currency service. And I know currency service has been having trouble with latency. So we're going to set a target on the currency service's latency. The product team is going to make the commitment that the currency service backend API is going to have a latency of 100 milliseconds or less 95% of the time for 95% of requests. So how do we do this? Well, first, because currency service is a known service type, Istio, it's already ingested by the API. So all we have to do is pull it out by querying within our services for a cluster Istio service that is named currency service. Next, we're going to build the SLO that we want to define. We're going to set a display name that describes in human-readable language the target that this SLO is actually going to measure. We're going to set a goal, in this case, 95%. We're going to find the period. In this case, it's a rolling period, so it's going to be over 3 days. In the last 3 days, starting from right now, going back, how has my service performed against this latency target? We're then going to define the service level indicator, the actual measure of what is my service doing. Because Istio is a known service type, what we can do is use a shorthand SLI, a basic SLI. We're going to say, backend, please measure my latency, and use a threshold of 100 milliseconds. This is the whole SLO definition. Then we go to the API, we call create service level objective, passing in the service's name and the SLO definition, and then we're going to see it saved. Great. So this is the SLO saved in our API. It has, of course, all the content that we just went over, as well as a full resource name with a UUID, which allows us to programmatically reference this SLO moving forward. We're going to use that right now, actually. The next step we're going to do is wake Shoucong up at 3 a.m. because his service is down. We're going to do that by creating a Stackdriver alert. So using the standard Stackdriver alert format, the only thing we're going to change is when we define the metric that is being queried by the API, we say, look at this SLO's burn rate. We say, select SLO burn rate. We pass in our SLO's full resource name, and we say, look at the last 10 minutes. So what does that mean? If we set a target of 95% under 100 milliseconds, if we were only achieving 90% under 100 milliseconds, our burn rate would be 2x. We are burning through our error budget at twice the rate we should if we want to stay compliant. So we're going to set an alert that looks for a burn rate that is greater than 7 over the last 10 minutes. We're basically looking for, my service is hard down. Please wake somebody up. Someone needs to look. We save the whole alert policy, including the display name, the SLO condition, using a reference, again, from the monitoring v3 API client, but this time to the alert policy service. We're going to save it and then take a look at the final constructed filter, making reference to the SLO we created just a second ago. There we go. Cool. So we can see the final filter that is constructed. We're using a metrics macro, essentially, saying select SLO burn rate. We pass in the SLO's full resource name, and we pass in 600 seconds to say, look at the last 10 minutes. That's the whole process. We now have currency service set with an SLO and an alert. Let's take a look. Great. So not only do we see that currency service has an SLO set, we can also see it's already out of error budget. The reason we can see that is because the service monitoring API does not start recording once you create it. What it does is look at the historically stored data of your service. So currency service has been running for a long time. It is an established application. We can set SLOs against it right now and understand how that service has performed against that SLO historically, immediately. All right. With another known service type, in this case, we're going to look at the front-end microservice under Hipster Shop. We can also set availability SLOs. These are even simpler. Again, we're going to define our display name in a human-readable way, 98% available, which means 200 responses, in 1 calendar week. So instead of a rolling period, which says, from right now, look back so many days, a calendar period says, Monday morning through Sunday night, how did I do? A lot of times, this can be more understandable for some business stakeholders. Whether you use rolling or calendar can be an open conversation. We're going to set a goal of 98. We're going to set a calendar period of 1 week. And the only thing we have to tell the service monitoring API, because this is a known service type, is measure my availability. We'll figure out what that means for you and measure it on the back end. We're going to call the API and save this SLO again. Great. So once again, what we've stored is the full resource name of that SLO in addition to the information we passed, which means we can use that programmatically moving forward. So we've shown you 2 basic SLIs. Your applications can refer to or have multiple user experience goals. Latency and availability are fairly universal. Every service cares about how often am I up and how fast do I respond. The Hipster Shop application has custom metrics that are measuring other business cases, like the full user experience of the Hipster Shop application tries to encourage users to purchase multiple items. I came to Hipster Shop to get super cool coffee beans, but hey, that vintage camera also looks great. That relies on the recommendation service returning quickly, but also returning good results. It relies on front-end application switching between pages in a seamless way so that the user doesn't mind browsing the website. So we can create a custom SLO against the front-end service to measure that business outcome. In this case, we're going to look for the custom metric on Hipster Shop of items per sale. And what we're going to say is, for this distribution metric, we're going to create an SLI that is request-based, so we're measuring per request. It's going to be a cut on the distribution, so take this distribution and see how many of my objects fall within a bucket, or my entities in the time series. And we're going to pass in the filter of the custom metric, and we're going to say, for this metric, I would like the items per sale to be 2 or greater for 90% of my sales. Completely custom metrics. Completely custom SLO. And once again, stored in the API with a referable full resource name. So we've talked about several known services, front-end and currency service. The other application that's running in this project is a GKE service running behind an ingress endpoint. This isn't automatically detected by the Service Monitoring API, but that doesn't mean we can't set SLOs against it. What we're going to do first is we're going to create essentially a bucket under which we're going to store our SLOs. So the pet shop application, you probably want an availability SLO, you probably want a latency SLO. We're going to join those together for you by creating a single reference under a service. We're going to create a custom service where the only thing we set is the display name. Here, human readable, understandable description of what you're looking at. It's the pet store application running on GKE. Great. So you can see it stored the display name, and it stored, again, the full resource name for later programmatic reference. The last thing that we're going to do is create an SLO against this custom service. I described earlier that Pet Shop is a GKE application running Kubernetes service behind an ingress endpoint. We know that because you're running on GCP, the ingress endpoint is automatically placed behind an HTTPS load balancer. So what we can do is we can look for the Pet Shop service, what is the load balancer it's hiding behind. And what we can do is we can build a metric looking at request count, looking at the backend target name that we know refers to the Pet Shop application. We're going to build an availability SLO in this case. So we're going to create a ratio, all the requests that have a good response against all of the requests made to the service in any context. And the only difference between these two filters is that our good service filter includes a requirement that the response code is 200. So we have a full description of a custom SLO for availability on a custom service type. Once more, we're going to refer to create service level object, passing in our custom services name and the SLO we've just constructed. Great. So in about 10 minutes, I've created 3 SLOs and 1 SLO alert, and we can see all of those appear in this view. Excellent. Unfortunately, none of my services are currently compliant, but we know that now, and I can show this, and I can say to my development team, please stop releasing. You keep breaking the service. Let's slow down until we have a chance to step back, review the service's behavior, and actually have it achieve both our development and our business goals. Ruxanda, would you like to continue?
Thank you so much, Elizabeth. So what we've seen so far is how to create SLOs. The second question is, we should think about scale from day one. And even though I told you, go home, pick one service, create one SLO, let's do that with the expectation that in a couple of months, we might have a few hundred. And how do we manage hundreds of services? I've seen dashboards with thousands of alerts firing. That's not a pretty thing to look at. But if we start thinking from day zero of how to manage for scale, we can build good, scalable best practices. So the CUJ that we're going to focus on next, how do I actually monitor health at scale across the entire fleet? So these are a few things that I want to talk to you about before we actually look how we do this in Stackdriver. The first one, and we touched about this at the beginning, is business-driven SLOs. Have a conversation with your partners within the company and try to understand what are the experiences from your end customers that you care about. And once you can identify that, document them and get them approved and understood by all of the members. The crazy thing about here is that you already have SLO set up and you don't even know about that. A lot of the alerts that you already have are already SLO alerts. And the first thing is as simple as doing kind of a review of every single alert that you have and renaming some of them as SLOs. You care about these things, or you already care about your end customer experience. So in some cases, and I think in the majority of cases, of the people in this room, you're going to go home and realize that it's absolutely fundamental to take care of the alerts that you have. The key here is not go home and delete everything and start from scratch, but try to reuse as much as what you have. Really smart people put in a significant amount of effort at creating fantastic alerts. Let's figure out how to make the best of them and introduce them into this mindset. The second thing, I hear this from customers all the time. I have 500 services. Which ones are worthy of an SLO? And my answer is all of them. But let's be smart about this. Not every SLO means an alert. Every single microservice should have an SLO on it because you want to do root cause analysis. If your front end is down, you want to see if the back end is down as well. You want to set these expectations of a best practice. But you're only going to alert on the SLOs that are fundamental to your business goals. Let's talk about user journeys. You have customer user journeys and system user journeys. The customer user journeys focus on the external user journey experience, and you're going to be able to really understand, okay, within a CUJ, there might be 3 or 4 steps. You're going to instrument those 3 or 4 steps with SLOs. So the moment one of your 4 SLOs attached to the CUJ is down, your entire CUJ is compromised. So don't think about SLOs as small pieces of information randomly showing up. These are part of a context. So if you have your SLOs in the context of a CUJ, then you actually understand what you are losing in terms of reputation, money, and things that you care about. Also, think about your CUJs within your company. If your billing pipeline doesn't work and you're not billing customers, your customers might be very happy, but your CTO might not be. So think about the different CUJs you want to track that are meaningful to your business goals as well. And the last one, system user journeys. You should treat your internal partner teams with the same care and dedication you treat your end customers. Your back-end and front-end team have made a contract between each other that my back-end is going to be available, so my front-end is available. And we need to ensure that moving forward, we don't have emotional conversations around who's to blame, but we all have the data to figure out how to collaborate together. So what can you set SLOs to today? The API that Elizabeth just demoed is in beta and would allow you to create SLOs on every single GCP service. It would allow you to create SLOs on Kubernetes Engine, Compute Engine, App Engine, on every single deployment for Anthos. If you have anything on-premise that is VMs or Kubernetes, we'll be able to create SLOs on those as well. And if you have any hybrid environments, you will be able to create SLOs on those as well. So what we're going to do next, Elizabeth is going to pull up a project, and we can actually look at how an environment like this works with SLOs. So we'll be able to see we have SLOs on GKE. We have SLOs, for example, the doc service is on EC2 on AWS, and then we have a doc service on GCE that's in the process of migration, and we're monitoring it. We have every single Istio service out of the box created right there. We are able to add custom service, like the ones that Elizabeth showed us. So let's pick one service, Elizabeth. And as we click into one of these services, we have integration with Stackdriver alerting. This will allow you to see all of the alerts in the context for this particular card service. And the event timeline shows all of the alerts that have fired in the past 6 hours. You can click on that card on any of the alerts, and you can learn more about the alert details, or you can go and make changes to the policies. Every single time you create an SLO, you get an SLO card out of the box. This gives you SLI, error budget, and compliance charts in the context. You can attach as many alerts to an SLO as you want and be able to monitor them in context. And the experience here is fully integrated with metrics, logs, and you can do this for every single environment. So what we have demoed today, what Shoucong has shown with custom metrics and custom dashboards is GA, and all of the SLO functionality is beta. The final thought that I want everyone else to walk out the way today is that this is a cultural change in terms of approaching your service health. You don't have to change anything about your deployments, anything about your infrastructure. You don't have to hire new people on the team. You can take your existing setup and be able to create a uniform way that is meaningful to the end customer to monitor your end customer experience. And with that, thank you so much for everyone that joined. I really appreciate. We are right at time, so I'm going to be right there taking any questions, but we're going to have to clear the room. Again, thank you so much.